Objective 4 out of Quadratics unit for the summative review. Again, this is the review. In Objective 4, you're going to use quadratic methods to solve non-quadratic functions. This is one of the reasons why when we did the factoring unit, you had to learn how to factor non-quadratics using quadratic methods. So, without further ado, let's take a look at this first one here. X to the fourth minus 9x squared plus 8. You can either factor it as is, or you can let a equal x squared. I'm doing that because x squared squared is x to the fourth. So it's in quadratic form, but it's just not a quadratic. That's okay. Now I have a squared minus 9a plus 8 is equal to 0. I can factor this quite easily. I can say that a minus 8 times a minus 1 is equal to 0. Factors of positive 8, I'll do this over here, factors of positive 8 that add up to negative 9 are negative 8 and negative 1. Since a is 1, I don't have to worry about anything else. Now I set each factor equal to 0. So a minus 8 is equal to 0. Oops. So a is equal to 8. A minus 1 is equal to 1. A is equal to 1. Now, I can't leave it here. If you leave it here, ooh, you missed the bulk of it. Remember that the whole reason that you substituted was to make the problem easier. Now we've got to substitute back. So x squared is equal to 8, and then x squared is equal to 1. Taking the square root of both sides, I get plus or minus 2, square root of 2, and plus or minus 1. For the 8, remember that the square root of 8 is the same thing as the square root of 4 times 2. The 2 can come out, which makes it 2 square root of 2. So this guy right here, that's where I got 2 root 2. Okay? There's your answer. Next one up, the square root of x and x. Remember that the square root of x times the square root of x is equal to x. That means the square root of x squared is equal to x. So, in this case, I'm going to let a equal the square root of x. Now I have a minus 10a plus 9 is equal to 0. Factors of 9 that add up to negative 10 are negative 9 and negative 1. A minus 9 times a minus 1 is equal to 0. A is equal to 9. A is equal to 1. Now I'm going to put the square root back in. Square root of x is equal to 9. Square root of x is equal to 1. Now here, remember that I have to square this. So I have to square both of these. When I do that, x is equal to 9 squared, which is 81. X squared is equal to 1 squared, which is 1. Remember, we're not taking the square root, we're squaring it. So far, so good? Excellent. Next up, we have the expressions. And these get a little bit crazier. But again, if I just look at these, they look awful. But if I simply say, I'm going to let a equal x minus 2, and I have a squared minus 3a minus 4 is equal to 0. And hang on just a moment. So, with this, I now need factors of negative 4 that add up to negative 3. That would be negative 4 and positive 1. A minus 4 times a plus 1 is equal to 0. A is equal to 4. A is equal to negative 1. You should be getting to the point once you factor like this that you know that a, x, b, whatever your variable is equal to the opposite of that number. Now I'm going to replace a with x minus 2. So x minus 2 is equal to 4. Add 2 to both sides, and x is equal to 6. Over here, a is the same thing as x minus 2. I'm going to add 2 to both sides, and x is equal to 1. Those are my answers. Number 4 just looks uglier, but it's not so bad. We get a is equal to 1 plus the square root of x. Whatever this expression is, I'm just going to let it be a, because it's the expression squared, and then it's the expression. So now you have a squared plus a minus 6 is equal to 0. Factors of negative 6 that add up to positive 1 are 3 and negative 2. A plus 3 times a minus 2 equals 0. A equals negative 3. A equals positive 2. Now I'm going to replace a with 1 plus square root of x. And over here, 1 plus square root of x is equal to 2. Now, I'm going to subtract 1, in this case, from both sides. The square root of x is equal to negative 4. Nope. This is asking for the principal or positive root, and this is a negative value. So, no, that one doesn't work. Let's try the other one. I subtract 1 from both sides, and the square root of x is equal to 1. Now I can square both sides, and x is equal to 1. Remember that the square root, the radical's already there, and there's not a negative in front of it, it's implying that you're looking for the positive root. Negative 4 is not a positive root, so we can't do that. Next up, number 5. Oh, similar problem. So we're going to have a equal to 1 minus the square root of x. So a squared plus 4a minus 12 is equal to 0. In this case, we have negative 12 has to add up to positive 4. That would be 6 and negative 2. A plus 6, a minus 2 is equal to 0. A is equal to negative 6, and a could be equal to positive 2. Putting this back in, I have 1 minus the square root of x is equal to negative 6, and 1 minus the square root of x is equal to positive 2. Subtracting 1 from both sides over here, I get negative square root of x is equal to negative 7. This I can take care of. I can take and divide both sides by negative 1, so the square root of x is equal to 7, and then I can square both sides, and x is equal to 49. Over here, I subtract 1 from both sides. The negative root of x is equal to positive 1. Nope. This is negative root equals positive value. Nope. Not true. So therefore, I only have one solution. Okay. Finally, we're looking at this last one, and I apologize, I didn't rescan this. This should be 6x to the 4th on your papers. It will say right here, this will be 13x squared. I changed it, I know, on the printouts. I just didn't change it. I scanned it before I changed it. So now a is equal to x squared. So I have 6a squared minus 13a minus 5 is equal to 0. When I solve, I'm going to set y equal to 0. Now, here, I can factor this, or I could use the quadratic formula. Remember, you can always use quadratic formula, but here I can factor it. 6 times negative 5 is negative 30. This is a times c, goes in here. b goes here. This is the value, negative 13. I need factors. I need factors of negative 30 that add to negative 13. That would be negative 15 and positive 2. But wait, a is 6. So I got to figure out how to deal with 6. So I got to bring 6 back into my equation. So now I'm going to have a squared minus. I'm going to reduce this. 3 goes into the numerator 5 times, into the denominator twice. Then I'm going to have a squared plus 2 will go into itself once, and it will go into 6 3 times. I need reduced fractions. Now, if I'm factoring this, I need to do bottoms up, but I'm not factoring it. Okay? I'm not, oops. Let me also do this. This should be just a. I'm not factoring it. I'm solving. So I can go ahead and just say that a is equal to 5/2, or a is equal to negative 1/3. What is a? It's x squared. So x squared is equal to 5/2, and x squared is equal to negative 1/3. Now, before you say, no, you can't at the negative, remember we know about imaginary units. So here, x is equal to plus or minus the square root, and we can separate this out as being negative 1 times 1/3. That means that x is equal to plus or minus I square root of 1 over square root of 3. We know that we can't leave a radical in the denominator, so I need to multiply by square root of 3 over square root of 3, which is a form of 1. And now, let me move my little recording guy over here. I have plus or minus I square root of 3 over 3. So there's one of my answers. On this side, x is equal to plus or minus the square root of 5/2. Again, since I can't leave the 2 in the denominator, I'll multiply by a form of 1, the square root of 2 over 2. And this will give me plus or minus the square root of 10. 5 times 2 is 10 over 2, because the square root of 2 times the square root of 2 is 2. So here are my 4 answers, 2 real, 2 imaginary. All right, that's it. That's using quadratic methods to solve non-quadratic functions. And again, on any one of these, you could also have used the quadratic formula. If you've got questions, be sure you bring them in and ask.